Hey guys, today's question is find score of an array after marking all elements. In this question, we are given with an integer array nums and our initial score is 0. And what we have to do, we have to apply the following algorithm. We have to choose the smallest integer in the array that is not marked. If there is a tie, we have to choose the one with the smallest index. Okay. And we have to add that value to our score, which is initially 0. And we have to mark that element and also its two adjacent elements, which are its left and right elements. Okay. We have to repeat this procedure until all the array elements are marked. Finally, we have to return the score of the array after applying all the algorithm. Okay. Now in this array, you can see 2, 1, 3, 4, 5, 7. So the smallest element is 1. So first we take 1 into our sum and mark these two elements. Okay. So these three elements are marked after taking the sum as 1. Okay. Score is 1. After that, we again found the smallest element. So smallest element is 2. Okay, so mark the adjacent element, this is 5 only. So these two elements are also marked and the overall score is 1 plus 2 is 5, and these two and these three elements are marked. So finally we are remaining with only this element, so we have to add this element, and after adding this, the sum will be 7, which is the output, and all the array will be marked. Okay, now we have to do this. So there are multiple approaches. First, we can simply make the pairs of the nums and the indexes, and then we can sort on basis of that, and then we can simply choose the elements and mark, and we can also choose the ordered map to store the whether it is marked or not marked, and we can also change the numbers to negative if they are marked, because the given range of the nums I is 10 to the power 6 from 1 to 10 to the power 6. So they all are natural numbers, so we don't need to use any visited array, like we don't need to take extra space for marking any element. Okay, we will simply change the value to negative of that value, and if we are currently at the value which is negative, that means that value is already marked. Okay, and after doing all the operation, we can simply change all the values to the positive to make the array as it was given previously. Okay, so now what we will use is the priority queue approach. Okay, as in the given, we have to, in the question it is given, we have to choose the smallest integer every time. Okay, and we all know the priority queue is a data structure that gives the smallest integer every time. So to make the code simpler, we will use a priority queue that the overall time complexity will again be n log n, and any other approach, they're all always the complexity will be n log n. So let's use a priority queue. So priority queue, and also we need to store the indexes of that elements to mark the element. Okay, also the priority queue sorts on the basis of the first element, and if the first element matches, then it sorts on the basis of the next element. So we will insert the pair of the element and its index, so that our approach works well. So first we will define the p as pair of int comma int that we have to use. Okay, now let's write the priority queue. We have to use a minimum heap, so p vector p and greater p. Okay, this is the syntax to define the minimum priority queue. Okay, now we got the minimum priority queue. We will simply insert all the elements with their indexes in the queue. So I0 I less than nums dot size I plus plus. Simply we will push pq dot push current element, which is nums of I, and its index, which is I. Now after doing this for loop, first we have to take the sum, initial sum as 0, so long sum equals to 0, and now we have to perform these operations while the size of priority queue is greater than 0. So while not pq.empty, we will perform these operations. Now first we will take out the element as pair of int comma int current equals to pq.top. Okay, now if the element is already marked, first we have to delete that one. Okay, now if the current is already marked, okay, first take the index of that element. So int index equals to, we have stored the index at the second value, so current dot second. Okay, now if the index if the value at that index is less than 0, that means it is already marked before by any other element. Okay, so then we have to continue. So if nums index is less than 0, that means that value is already marked, so we don't need to add it into sum, so simply continue. And now if that value is not marked, if we don't continue, that means the nums of index is greater than 0, then we will simply add it to the sum. Okay, sum plus equals to nums of index. Okay, the index is the current element of that element which was at the top of the priority queue. Now we have to mark the adjacent elements, but the edge case is if we are currently at this position, we can't mark the left element because it is out of bound, and we are if at the last position, we also can't mark the right side. So simply we will do checks. If index minus 1 is in the range greater than equals to 0, then we will mark that element. Okay, so how we will mark? Let's say we choose this element and this 4 gets marked. Okay, uh, and let's say here it was 1 and we'll again choose this element and this 4 again will get marked. Okay, but we don't need to change the value again. If we mark it 2 times, that doesn't mean it will be unmarked. Okay, it value will again be marked, always be marked. So we have to change it to the minus of this value only. Okay, now if we change it to the minus of nums I, what will happen? It will become minus 4. Then again if it gets marked by this 5, it becomes 4. But we need to change this element to minus 4 only. So we will simply change it to the minus of absolute value of this element. That will always change it into the negative element. Okay, so if this index is in the range, so nums of we are simply marking that element, so id minus 1 equals to minus of the absolute value at that position. We have to use this absolute value because an element can be marked twice. Okay, now also for the right index, idx plus 1, this should be less than the size nums dot size. If this condition holds, we have to mark that element also. Nums of idx plus 1 equals to minus of the absolute value at that index. And finally, after this while loop execution, we can return sum. You can also change all the elements in the nums to the positive value, which is the absolute value, but we don't need to it in this case. Okay, let's submit this question. So the code is accepted. Thank you for watching.